Today, this 105th episode will be talked by Mr. N.B. Sarolkar. Green hydrogen is a buzzword in automotive industry today. There is a lot of things happening in the battery technology, and recent sodium battery developed by Indians is going to be a challenge because India's dependency on lithium will reduce drastically. Today, the lithium is owned by China as well as Argentina, and India, we have to import that. Once this battery is proven, probably the demand for electric vehicle will also grow. Considering the war situation, the petrol prices are likely to go, and India must find the alternative. The second alternative considered, rather that may be the first one, is green hydrogen, and it will also change the total scenario of automotive industry. Today, Mr. N.B. Sarolkar is going to talk about the green hydrogen opportunities for SMEs, because there are a lot of people wanted to enter into the new technologies, especially the young entrepreneurs, and this lecture and presentation will be very much useful for the young entrepreneurs to start their venture. I have already circulated the basic introduction to Mr. Sarolkar, but however, our energy cell in charge, Dr. Pramod Deshpande, is going to introduce formally to Mr. N.B. Sarolkar. Without spending much time, I will request Mr. Deshpande to introduce today's speaker, Mr. Sarolkar. Over to you.
Good morning. I welcome Mr. Sarolkar for this presentation. N.B. Sarolkar is a mechanical engineer who has worked in Kenya on number of projects and also in his driving force is the projects for the development. And that is why he is very much in the field of startups or developing the new technology, which requires a project management as well as the understanding of the new technology and its market and things like that. At present, green hydrogen is a buzzword, and it is being buzzword because of the climate change. And there are a lot of developments are taking place on development of the green hydrogen. Second most important thing is that this generating the hydrogen one way is a age-old known technologies. Some of the technologies are getting developed, and that is why utilization of hydrogen is known. Those people have a certain fear about handling hydrogen, but more important is that what are the components and things can be developed by which the SME can grow in green hydrogen. And that is the key requirement. And now I request Sarolkar sir to give his presentation on important topic, which is not a technology, but an opportunity in green hydrogen to the business people. Thanking you. Over to Sarolkar sir.
Thank you. I thank Tech Forum to give me opportunity to spread information in the entrepreneur world about green hydrogen opportunities. Currently, green hydrogen market is valued at 7.98 billion as at 2024. It is growing at a very high speed of 38.5% and likely to be a market of 199 billion by 2034. Government of India wants to be a export hub for hydrogen and the electrolyzer, and that is the reason government has created a green hydrogen mission where they have allotted 19,744 crore rupees to this mission. We will discuss all those details afterwards, and as Mr. Rabde was saying, no doubt the hydrogen is our ultimate goal even for mobility, and EV was our only stepping stone. So why the hydrogen is goal? Because for generating hydrogen, we are taking water from the atmosphere and giving input as a renewable energy. The water is split into oxygen and hydrogen. since there is no carbon generation during generation of the hydrogen, it is called green hydrogen. When you consume this hydrogen, you are taking out the water from the atmosphere, mixing with the hydrogen to generate heat and energy, and the exhaust is pure form of water vapors. So now we start our discussion on the opportunities in SME for a green hydrogen vertical. As I said, this market is going to be 199 billion market by 2034 and growing at a very high speed of 38.5%. Why everybody and the government of India and worldwide people are going behind hydrogen? Because hydrogen is used for power generation, hydrogen is used as a synthetic fuel, hydrogen is used for hydrogen vehicles, hydrogen can be used for heating purposes, hydrogen is used in the metal refineries, hydrogen is used for metal fertilizers also, like ammonia and all. So hydrogen has a multiple usage, and hydrogen has a capacity and capability to decarbonize the planet. Now, why India is focusing on hydrogen and why hydrogen is must for India? The hydrogen can minimize 160 billion and growing bills of energy. Hydrogen can help us to increase our renewable energy generation from 92 gigawatt to 450 gigawatt by 2030. Hydrogen can help India to become a clean energy leader by reducing 3 gigatons of equivalent of carbon. Now, when we say 160 plus billion of energy, it is a huge figure, and how it is contributing we'll discuss in this slide. The crude oil imports are at 112 billion. 50% of the crude oil imports can go down with the hydrogen usage. The natural gas or LNG imports are at 9.6 billion, and this can be replaced 100% by hydrogen. The coal imports are at 23.6 billion, which can be replaced close to 25% with the hydrogen. The petroleum product is at 16.2 billion, and there is a possibility of reducing almost 75% of the petroleum products. The ammonia and other things, the usage is close to 1 billion, and there is a possibility of replacing 100% by green hydrogen. India is betting big on hydrogen basically because India wants to have the energy security, to achieve the emission targets, to have the economic development and the balance of the trade, and to minimize the energy subsidies. We know that government of India has committed for reduction of 35% of carbon generation compared to 2005 figures by 2030. And if we want to reduce this, then hydrogen is the only solution. That's one of the main reason why government of India is putting lot of funds and supporting industry to go for hydrogen. The economic dependence and the balance of trade will also happen with hydrogen because imports of oil, as we checked in the last slide, will minimize. And with minimum imports, naturally our trade balance will improve and we will have a better foreign reserves. India gives away a lot of energy subsidies, and for giving this subsidy, government is spending a lot of amount from their own pocket. So once we have the green hydrogen generation, the cost of energy generation would reduce and the energy subsidies required will minimize. Now, which are the drivers for green hydrogen in India? Green decarbonization target, complementary solution to renewable energy, supporting grid load management via energy storage, decarbonization of hard to abate sector like mobility, technological advancements, and falling technology costs for generating green hydrogen. These are the drivers which will push green hydrogen movement in India. We know that globally, the global warming is a big issue, and all the countries in the world are pushing to minimize the carbon generation and maintain the temperature rise to 1.5 degree. To achieve this target, hydrogen is one of the important factor, and the hydrogen economy and hydrogen usage will help uh, countries to minimize their carbon generation and help in decarbonizing not only the automotive sector, but the entire sectors, you can say, like fertilizer, like industry, like glass industry, pharmaceutical industry, aviation industry, marine industry. All type of industries can be decarbonized with the hydrogen. Complementary solution to renewable energy. The renewable energy is available only for a particular time, and we need to store this energy when it is available to ensure that it can be used when the renewable energy is not available. And hydrogen can be used in a great way for storing the energy. Hydrogen can be used for supporting grid management and decarbonizing also. The hydrogen energy storage system will help to minimize the load management on the grid. And when the off peaks are there, it can store the energy, and when the peak loads are required, it can release the energy. Hydrogen has a potential to work as a feedstock to reduce the carbon intensities in the sector of transportation and residential application. The transport sector is closely contributing 40% of the carbon generation, and decarbonizing mobility sector and transport sector is one of the important criteria. Hydrogen vehicles are already plying on the road. Hydrogen mixed with CNG is already available in Delhi for last more than 2-3 years, and it has reduced the transportation pollution in Delhi. So decarbonization is one of the important thing in the mobility sector. The technological advancement in the electrolyzer is also going to push the market, because the energy required to generate the hydrogen is improved a lot now, and people are continuously working on minimizing the energy inputs and improving the efficiencies. The technology cost is also going down drastically. The electrolyzer, which were costing 20,000 euro per kW few years ago, they are now close to 50% at the earlier prices. Once the volumes will increase and the manufacturing will increase, automatically the technology cost is going to go down. The second reason why the technology cost is going down or the hydrogen cost is going down is the renewable energy generation cost is going down drastically. The National Green Hydrogen Mission was established by Government of India, and the main target for the Green Hydrogen Mission is to develop the hydrogen generation capacity in India and make India as an export hub for green hydrogen and the electrolyzer. Government is targeting to export 5 million metric tons of the green hydrogen by 2030, which is close to 10% of the global consumption. India wants to even become an export hub for the PEM electrolyzer, which is one of the best technology available for splitting water into hydrogen. And these electrolyzers demand in the worldwide is likely to be close to 120 gigawatt of electrolyzer by 2030. And India is planning to support almost 20 to 30 gigawatt of electrolyzers, which is definitely going to be a huge amount. The cost effectiveness of Indian manufacturing is also going to be one of the important role in export, because the labor cost in India is low compared to the European market, and the energy cost, renewable energy cost, especially the solar energy cost in India is comparatively low compared to other areas. Currently, the levelized cost of energy in India is close to 1 rupee 70 paisa, and it is still likely to go down. This will help India to generate the hydrogen at less than $2 per kg in next 2 years. Currently, the cost of hydrogen generation is close to $4. And targets by Government of India as well as the world is to have the hydrogen below $1 per kg in the next 10 years. Now in this slide, we will see what are the financial benefits the government is giving to push the hydrogen economy. As we said that there is a 19,744 crores of the funds are allocated for National Green Hydrogen Mission. And out of this 19,000 crore, 17,000 crores is given for domestic manufacturing of electrolyzer and production of green hydrogen electrolyzers. So this is a huge amount. And with this funding, the SMEs and other industry can definitely grow in a big way. The balance amount is 1,468 crore is for the pilot projects, 400 crore is for R&D purposes, and 388 crore is for other applications like skill development and all. With this, government is planning to export 5 million tons of hydrogen annually starting from 2030. It would help reduce 50 million metric tons equivalents of gas emission. It will help generate 8 lakh crores of the jobs in India. And along with the job generation, it will help for the exports also and converting Indian industry. Government has already given a mandate, industry-wise mandate for conversion of existing fuel with green hydrogen. India's green hydrogen market is definitely a huge market, indicating a value of close to $8 billion by 2023 and $340 billion by 2050. National Green Hydrogen with an outlay of 19,744 crore is a key initiative driving this expansion. In India, the hydrogen business is growing at 20.76% between a period of 25 to 30, means from today for the next 5 years. The current market is 1,400 million in India, which is supposed to be grow to 25,337 million by 2050 at a CAGR of 39.5%. 39.5 means close to 40% of the business will increase every year till 2033. The investment in green hydrogen and ammonia capacity is estimated to be approximately $34 billion in India by 2030. And out of this 34 billion, 9.3 billion will come from the public investment, which is definitely going to be a huge amount. Adanis have already started working on this project. Reliance has already started working on this project. Greenco is working on this project, and there are other companies, those who are working on the mega projects for generating hydrogen and electrolyzers also. The electrolyzer market that way is not that in India because there are hardly few companies, those who are working on electrolyzer. The India's clean energy market is considered to be $80 billion by 2030. And out of this $80 billion, $19 billion will be contributed by the hydrogen itself, as per the Morgan Stanley report. So close to 24% clean energy will come from hydrogen. The $80 billion estimate is from International Energy Agency. The International Energy Agency and Morgan Stanley both are one of the prominent agencies, and their forecasts are always very close to the actual figures what the countries will achieve. So if we see the global requirement of the hydrogen, the market size last year, that is on 2024, it was 7.98 billion, so close to 8 billions. The global economy on hydrogen is growing definitely at a 38.5% CAGR, and this will grow for next 5 years with the same CAGR. With this growth rate, the hydrogen economy is going to be 199 billion by 2034. Now, after considering the hydrogen market, the hydrogen generation, the government policies and all, we will now touch what are the green hydrogen verticals, what are the areas where the entrepreneurs and the SMEs can be benefited, and where the SMEs can play the important role. The green hydrogen vertical is considered right from renewable energy generation, which is one of the major components required for the green hydrogen, and up to the end, it means up to the application of green hydrogen in the field. It can be for industry, it can be for automotive purpose, it can be for any other purposes. So right from input energy to hydrogen application, which is going to be a very, very big area. We will discuss this in detail in the further slides. So the hydrogen vertical will consider renewable energy, water electrolysis by electrolyzer. There can be different electrolyzers like PEM technology, which is one of the latest and proven technology. There is an alkaline electrolyzer also, there is a solid oxide electrolyzer also, and there is an anion exchange technology also. But all these technologies, alkaline technology is proven, working for last couple of years in India also. But the disadvantage in that the capex is low, but however the operating costs are very, very high, and the maintenance costs are very high. Plus continuously we need to use the alkaline material, and when we are producing this alkali, there is a carbon generation. Because of that, the PEM electrolyzers are well accepted in the market by worldwide. Once you produce the hydrogen is produced at a very low pressure, but the electrolyzer itself will build up the pressure, and in case of PEM it will be released at 35 bar pressure. In case of alkaline it will be released at 15 or 18 bar pressure, and this hydrogen needs to be compressed for transportation and other application. The compression of hydrogen is normally done to 350 bar or 700 bar, and for compressing the hydrogen from this, say about 18 bar or 35 bar, we need to compress it to 700 bar, means we need minimum 20 times compression in case of PEM and 40 times in case of alkaline electrolyzer. The hydrogen compressor, although same principle using, but it requires a special material because conventional materials has a hydrogen embrittlement issue and it will fail if it is used for the hydrogen. So you need to modify a lot of components in the hydrogen compressor to ensure that the compressor will give a lifelong operation. So after you compress, you need to have the storage and transportation of the hydrogen. The hydrogen storage and transportation is done with a different technologies. One is, as we discussed, is the compressed hydrogen. Second is the liquefaction of the hydrogen, cryogenic hydrogen. The hydrogen is chilled to minus 256 degrees or more to convert it into the liquid. So the energy required for liquefaction and maintaining the hydrogen at that temperature is comparatively very high. The third form is the storage and transportation in metal hydrides, where it has a very high density of storage and the retrieval of hydrogen from metal hydrides is comparatively easy. So these are the three main areas used for storage and transportation. Then when you want to use the hydrogen, the dispensing is one of the important issue or one of the important area. So hydrogen dispensing is done at different pressures. If you want to use it for mobility, it is done at 350 or 700 bar. But when we want to use it in the industry, the pressures are drastically reduced. In float glass industry, the pressure will be 1.5 bar. In steel industry, the pressure will be 8 bar, and like that, the pressures will go on varying depending on the application. So the hydrogen dispensers are one of the important area. And the hydrogen dispensing equipment is something similar to your CNG pump, where we are filling CNG at about 120 to 160 bar, but hydrogen will be filled at about 350 or 700 bar, depending on the type of vehicle or basically depending on the storage system used or the cylinders used. The next vertical is the hydrogen application for energy, chemical, fertilizer industry, etc. Hydrogen is main element for fertilizer. Hydrogen is main component for ammonia. Hydrogen is used for a lot of chemical industries, like we said. Hydrogen is used for metal industry, in steel industry, etc. So hydrogen application in industry is also one of the very important area which cannot be ignored. The next application of fuel cell, hydrogen is fuel cell. Fuel cells are used for automotive purpose also and for energy generation also. One of the important application of fuel cell now coming up in a world in a big way is microgrid. You have a small plant of the energy generation which may have a capacity of 10 kilowatt or 100 kilowatt. It will be supplying to the nearby villages, maybe 10 villages or 20 villages or something like that. And the energy supply at the remote locations can be done with the microgrid without laying the very costly grids. This is one of the very important aspect in the energy security. The fuel cells are used even for the automotive purpose, for transportation of heavy vehicles. Ambani's or the Reliance industry has already converted their heavy duty transport haulage on hydrogen. The hydrogen buses are plying between Pune and Bombay nowadays on a trial basis. The hydrogen port is already working, and a lot of initial activities in the south, which is one of the hub for major movement of the goods, is working on the hydrogen. So fuel cell application is also one of the very important application in hydrogen, and manufacturing the fuel cell and components required for its application is a very big area. We'll discuss this in the further slides. Now, how SMEs can have opportunities in this hydrogen? It can have a cross-sectoral application. It can have R&D partnerships. It can have a local manufacturing sector also. Now, in cross-sectoral application, it can create enhanced application by combining sectors like integrating transport and energy storage, combining industry and utility sector, developing hybrid solutions, etc., etc. In R&D, there are a lot of areas where India can work, that is technological development in partnership or individually. Government is already giving a lot of grant to universities and prominent institutions like engineering colleges like COEP Pune or MIT World Peace University, etc., to work on the hydrogen and the related areas. The R&D can work on development of the low-cost electrodes. Electrodes is one of the major component, which is one of the very costly component. So there is a huge possibility of working on the electrodes. There is a possibility of working on the control system. There is possibility of working on the membranes, the coatings, and catalyst and other areas which we will discuss further. In local manufacturing, we can develop the improved cross-sectional applications like component manufacturing, maintenance, system integration, etc. Because the electrolyzer is a combination of lot of small components. The one component is membrane exchange assembly, which is responsible for generating hydrogen and oxygen out of water. This MEA will be coupled with lot of other components like bipolar plate, end plates, etc., etc., to form a stack. Then all the stacks will be combined to make a module. The module will be attached with multiple modules to make a plug and play system by adding the components, etc. So in local manufacturing, there is a huge market, which we will definitely discuss in the following slides. Now, potential business opportunities we'll discuss head by head in these slides. SME definitely can engage in various areas of green hydrogen, and the key opportunities will include like infrastructure development, renewable energy integration, manufacturing of components and equipments, manufacturing of electrolyzer components, manufacturing of balance of plant. As I said, the module will have a lot of other attachments. So those other add-ons are considered as a balance of plant. This includes thermal management system, it includes control system, etc., etc. Then the storage system, fuel cell components, logistic and transportation. These are the areas where SMEs can definitely contribute. The other areas are refueling solutions or refueling station, last mile delivery of hydrogen, green hydrogen production with mini plants and pilot projects. It is important to mention here that pilot projects are funded by the government up to 50%. Ancillary services and supports, consulting and advisory services in the hydrogen vertical, preventive and plant maintenance and repairs of the hydrogen systems. Hydrogen systems requires a routine maintenance and the plant maintenance to ensure the plant will run continuously. And majority of the manufacturers, they themselves offer the remote monitoring system. However, after remote monitoring system, the physical maintenance requirements are there. And if these systems are developed on a local area, then the cost of maintenance can drastically reduce. Research and development. as we say that there are a lot of components which are imported, and doing R&D on the import components and doing import substitution is going to be a very big area which can benefit the SMEs. Skill development and training. As on today, the skills required for hydrogen generation, hydrogen maintenance are not available in India because the field was not operative in India. But in next 5 years, there is going to be a very, very huge requirement of skilled staff for hydrogen generation, hydrogen maintenance, and hydrogen application. That's one of the important area, and that is the reason government is putting 388 crore for skill development. Majority of the institutions like IITs and prominent engineering colleges, they have already started a special course on hydrogens, but all those skilled which will be developed through these institutions is still going to be in a limited way. So the private industries and SMEs has a very big scope for skill development. Then next area is end use application. As we say, the end use of hydrogen is in multiple places: for fuel cell application, for energy generation, for energy storage, for chemicals, for industrial use, etc., etc. So the end use application is one of the very, very big area, and it can be a very good option for SMEs to work on this. Mobility is definitely important for government also and for us also, because EV is a stepping stone and hydrogen is the only target for all the countries in the world, because the emission from fuel cell or emission from hydrogen used in mobility is a most pure form of water vapor, which is pure hydrogen H2O, means water, and this water is potable grade water. Just for your information, the spacecraft people, they use water in the spacecraft generated out of this hydrogen usage from the fuel scale. Then industrial feedstock for making the fertilizer, for making ammonia, etc. Hydrogen is used as a feedstock. Power generation from hydrogen. Power generation from hydrogen can be through fuel cell or without fuel cell also. And power generation is again a big area, because India is growing and our power requirements are increasing day by day. So power generation is also going to be a very, very big area. When we say discussion about electrolyzer manufacturing, so here we will discuss what are the components of the electrolyzer, how the electrolyzer is formed out of the electrode, and what are the areas where the SMEs can work. So we have an electrode, we have a membrane, we have a catalyst. The catalyst is coated with the, membrane is coated with the catalyst, and the electrolysis is filled within the membrane and within the electrode. Electrodes are submerged in the electrolysis, and this forms, after adding a gas diffusion layer, it is forming MEA. MEA is membrane exchange assembly, which is a basic cell for the fuel cell or for the hydrogen electrolyzer. These multiple MEAs are connected together to form the stack. Now for making the stack, we require bipolar plates at the end of the MEA. We require multiple MEAs. Then we require add-on gaskets and the end plates to make one stack. These multiple stacks are connected together to form a module. Now on the stack, again, there are a lot of add-ons and multiple stacks are connected together to make a module. The multiple modules are connected together and a control system, the thermal management system, safety system, etc. is added, and then it is packaged in a nice housing to make a plug and play system. On this packaging, you are giving power terminals, you are connecting input and output for the utilities, you are connecting exhaust for the application, and then it is forming a complete plug and play system. This plug and play system is moved to the site, and when you give utility connection and the power connections, then it can be used for generating the green hydrogen. So in manufacturing MEA, we have possibility of working on the membrane, we have possibility on working on electrode, we have possibility on working on gas diffusion layer. The bipolar plates can be manufactured by SMEs. The add-ons can be made by SMEs like control system, the sensors, etc. The stack and the multiple stacks, when we are converting into module, we require a hydrogen precision presses to ensure that the stacks and modules are compressed with a particular pressure, and it will not leak when the hydrogen is generated. So you need a positive pressure and a positive tension on the tightening bolts. So this also is a very simple way. If you say hydrogen presses and the hydraulic presses are available everywhere, only thing we need to improve on the precision of these presses. The control system is something similar to BMS, which requires thermal management system. In some cases, it is water-cooled system. In some cases, it is air-cooled system also used. The heat energy generated is definitely need to be extracted, and you need a system to extract the heat generated from either from the electrolyzer or from the fuel cell. So thermal management is one of the important area. If we consider the hydrogen vehicle, there are a lot of components which we can make for hydrogen vehicles in SMEs. Electronic control unit, electronic pressure regulator, hydrogen tank subassembly, hydrogen tanks which are a special tank of fourth generation, hydrogen injector, pre-bent tubes. These are tubes which are used for transportation of hydrogen from one point to second point, and they need to be with a special metals which will not have a hydrogen embrittlement problem. Then the pressure transducers, the refueling panel, high pressure hydrogen panel assembly, liquefied hydrogen pressure relief valve, service defueling port. If you want to do the servicing when it is pressurized, you cannot do it. So you need to depressurize the system. Then mechanical pressure regulator of hydrogen at 700 bar, purge valve system and isolation valves. Lot of sensors and control systems are required for the hydrogen vehicle. And these all components can be manufactured by SMEs and developed by SMEs. There is no need to import everything from the overseas. With import substitution of a lot of these components, the cost is definitely go down. Now, key components and raw materials used in the green hydrogen supply chain. We will discuss this basically for the electrolyzers and storage and transportation system, because time will not permit us to go for further thing. The electrolyzer is made out of catalyst, electrodes, membranes, etc. As we discussed earlier. The raw materials used for the electrolyzers are very, very precious metals like platinum, iridium, nickel, cobalt, iron, polymer, stainless steel, etc. The one of the very, very important component in this, or very costly component, is the electrode, which use the titanium, platinum and iridium for the electrodes. So development on the electrode materials is definitely going to have a big impact on the costing of the electrolyzer. Hydrogen storage and transportation. High pressure tanks, cryogenic systems, the pipelines, the compressors, pumps, valves, fittings, and safety mechanism. These are the areas in storage and transportation which can be definitely useful for SMEs to work on. The materials used for this, basically for hydrogen storage cylinder, it is a combination of carbon fiber, carbon composite, the aluminum, and aluminum alloys. So basic raw materials used for this are the carbon fiber, fiberglass, steel and aluminum, and special alloys for storage of the hydrogen. The other areas are balance of plant. Balance of plant includes the thermal management system, which is basically a liquid coolant is circulated at a particular pressure. So the coolant system, the circulation system for the coolant, the positive pressure, high flow pumps for the coolant, the control system, etc. is coming into the balance of the plant. Power electronics is one of the very important criteria, very important item in the system. Especially in Pune, we have a big electronic hub, and power electronics required can be developed at low cost in India, especially in Pune. The water treatment system. The input water quality needs to be a potable water, and water treatment system is one of the important input for the green hydrogen project. So working on the improving the quality of the water and reducing the cost of the treatment can definitely help, and SMEs can definitely work on it, because there are a lot of people doing RO and other water treatment services in India. Heat exchanger and cooling systems. As I said, during the power generation, the fuel cell will develop 33 kilowatt of energy out of 1 kg of hydrogen. But this 33 kilowatt of energy is not 33 kilowatt of electrical energy. Depending on the efficiency of the fuel cell, it will generate between 15 to 18 kilowatt of energy in electrical form, and between 18 to 15 kilowatt it will generate the heat energy. So this heat energy needs to be utilized elsewhere, and heat needs to be transported from the fuel cell. So heat exchanger and the cooling systems are very, very important, and it can be a big area for SMEs to work on. It requires a lot of control systems and automation. So the control system and automation is also one of the areas where India and the SMEs can work. The hydrogen dispensing. As we said, if you have a hydrogen, it needs to be dispensed at a different pressure for different applications. So using the pressure reducers and dispensing at a particular pressure and in a controlled format is one of the important areas. I personally feel it is not a very difficult task to generate or to develop the hydrogen dispensers in India. Now, after discussing these areas, the import substitution is going to be one of the very big area for green hydrogen mission. And the benefit of import substitution are going to be cost reduction, job creation, technologically self-reliance, economic growth, and export potential. So import substitution is one of the very, very important area where we need to work. As we discuss, currently world is manufacturing less than 10 gigawatt of electrolyzers. The demand is going to be 100 gigawatt by 2030. So there is a big gap. Out of this 100 gigawatt requirement, 40 gigawatt can be made by European Union, 25 gigawatt will be made by Chile, 5 gigawatt can be made by UK. This totals to 70 gigawatt, and the balance 30 gigawatt India is targeting to manufacture and export to the world. So manufacturing the electrolyzer is also going to be a very, very big area, and that's one of the reason why government is pumping so much money in green hydrogen mission. Secondly, it is important to note here that PEM electrolyzer technology is the only technology which is controlled in European segment, and China has no hands on the technology as at now. More than 80% of the patents on green hydrogen by PEM is controlled or is maintained by European Union with them. And if we can work on this electrolyzer development, it is going to be a very, very big export opportunity for India, and that's the reason we are pushing this and the government is pushing this. Now, how SMEs can work in this large scale green hydrogen projects? Because people say that the green hydrogen projects coming are majority of them are giga projects. But yes, these giga projects will require support for local manufacturing and sourcing, innovation and customization, for supplying the skill required, for economic development, flexibility and agility, and decentralized solution. So SME can work on these areas to support the gigafactories, and this is one of the very important area where SMEs can support. Now, which business model is applicable for or suitable for the SMEs? Component supplier, service provider, niche producer of small scale hydrogen, integrator combining various components, distributor and retailer. These are the areas where SMEs can definitely play very, very important role. The key success factors are technology innovation and differentiation, strategic marketing positioning, strategic partnership. SMEs can have a maturity framework between startup to 2 years. It can work as a startup, and after third year, between third to fifth year, it can work on the growth strategy. With this, I conclude my presentation. If there are any questions, they are welcome. I hope I have given a broad guideline on a very, very big subject in a very limited time, and 40-45 minutes to discuss on the hydrogen sector is really not adequate, but we have tried to give the as much as information possible within this limited time. If you want, you can contact me afterwards either by email or over the phone. My phone number and email is displayed here. Over
Thank
to
you, Mr.
Bharat
Sarolkar.
Deshpande and Vilas Rabde.
Thank you, Mr. Sarolkar, for this excellent presentation and excellent overview for the opportunities. I think your presentation will help the university people to draft a syllabus, and this is going to be an opportunity for our education industry as well as the industry to focus in these opportunities, and definitely SMEs will benefit, and we need to improve our knowledge in this field, and India could be one of the big exporter of the opportunities you mentioned. We will throw upon the stage for the question and answer. I request participants to identify yourself and then raise the question. Please ask your questions.
Yeah, can I ask?
Yeah, please.
Yeah, my name is Makaran Parkhi. So, Dr. Sarolkar, Mr. Sarolkar, this was really good insight about this hydrogen. One of the point while I was going through your presentation and some information which I've gathered is hydrogen handling contains a lot of risk. So there is a lot of risk in storing and handling the hydrogen. Couple of things is because of the hydrogen being very small, the any storage material, it becomes you require a special item or special material to handle or store this hydrogen, then hydrogen flames are invisible. So you really don't know when the hydrogen gets leaked. And another one is because of the boiling and melting, I mean, boiling point of hydrogen is very low. At an ambient temperature or a room temperature, it becomes very difficult for hydrogen to handle. So how do we address all these risks when we see that SME can contribute in hydrogen manufacturing or hydrogen economy?
There are a lot of sensors available which will sense the a very small leakage of hydrogen. Very small means in the ppm area capacity, because not only it is not the hydrogen is very highly inflammable. The hydrogen flame is 10 times faster than the fuel flame like petrol or diesel, and definitely there is a very high risk when we are generating hydrogen, we are storing hydrogen and transporting hydrogen. So the control system becomes very, very important. And for this control system, the usage of lot of sensors are there, and the control system has to be a very good. That's the reason I said in the presentation, the development work for the hydrogen system is also going to be an important area.
So can I ask one question? The
Yeah.
hydrogen is already being used in variety of industries. So they must be handling this hydrogen through variety of storage and pipelines, etc. So I'm sure the technology is already available.
The technology for hydrogen storage and transportation is available, no doubt. The hydrogen currently
With
used by
appropriate care.
majority of the industry is coming in a canisters like your CNG is coming in a cylinders, and then they are connected to the application. Once the cylinders are getting empty, they are replaced. So the control systems are already existing, but
Correct.
what is happening, majority of the control systems are coming from overseas and the cost of those systems are high. So developing a system at a low cost is definitely possible, and there is scope for it.
Yeah.
Considering the volumes what we are expecting in the next 5 years, the requirement is going to be huge. Government is planning to have CNG pump converted to hydrogen pumps in next 10 years. If we consider the present number of petrol pumps in India, there are close to 20,000 petrol pumps. So those 20,000 petrol pumps will definitely convert to hydrogen. So 20,000 is definitely required for only the fuel station application. The industrial application requirement will be totally different. The export requirement is going to be different.
Oh, thank you.
I think, yeah, I think that answers the query. Any more questions?
My name is, okay. Am I audible?
Yeah, oh, yes, Madhuri.
Yeah,
You
my
are
name is
audible.
Madhuri. I was listening. It's very interesting topic. Thank you for taking up this for the discussion. And you mentioned about the micro projects which can become the inner help rural area. I'm thinking it from that point of view. To become the energy efficient alternative, because practically there are a lot of issues in the rural areas where the solar is not working as a good substitute because of 2 3 issues. One is the investment, one is the maintenance, and the support mechanisms are not available. I'm going through this myself. So I'm more interested to know about the details of the micro projects which you mentioned, the feasibility of that, and the
Yeah, Madhuri, this microgrid project is one of the important sector which government also has planned for hydrogen application, knowing well that the renewable energy is not available everywhere in a required format, and it needs
yes,
to be stored and dispatched controlled, etc. So the
Yeah.
microgrids are important for a country like India, where the grid is not laid everywhere.
Yeah.
And the Northeast Indian governments are already working on it. There are 3 projects going on as on today in Northeast for a grid application. And one
Mhm.
project is being planned in down south for grid application. I think by next year, either March or something like that, they will be operational.
So,
The
where
grid,
can I get the
microgrid will be
normal?
using basically hydrogen and fuel cell combination. The fuel cell will generate the energy and deliver the energy. The
Yeah.
advantage of fuel cell, as long
Huh.
as you supply the hydrogen to it, it will go on generating the energy.
Yeah.
So
I
all
think
24 hours.
Madhuri, you have a specific question. You can contact Mr. Sarolkar after our discussions because
Yeah.
it requires a long time to answer. But before
Discussion,
closing,
I
before
understand.
before closing, you just introduce yourself.
Yeah. My name is Madhuri Dandekar. I'm a chartered accountant. I have worked in industry for more than 25 years. Now I work as a consulting CFO, but I always try to make it a point to attend these discussions. I've run the manufacturing plant also. I have a small startup manufacturing. I'm also a farmer. So this particular question came from my this farming background because that is where I'm facing a lot of issues.
Yeah.
Yeah.
So I
So
think with this qualification, you are the potential customer for microgrid application. Probably you can discuss separately with Mr. Sarolkar because we are coming to, we already exceeded our time. Any more questions? We will take the last question now.
One last question from my side.
Yeah, please go ahead. Identify yourself.
So my name is
Makaran.
Makaran Parki.
Yeah.
Makaran Parki, and if I remember correctly, some 2 or 3 years back, government introduced near Pune a hydrogen valley project, and they have also made some announcement about the infrastructure and all those things will be developed.
Yeah, I think because I see hydrogen policy is very old. It is 2008
Kurkum
India
industrial
laid
area
down the
is
policy.
considered as a hydrogen hub.
So what's the status as of now currently?
Status as of now, the hydrogen hub is working in Kurkum area, and the industries which are there, they will be converted to green hydrogen very soon. This year it will start converting from the next month it will start converting to green hydrogen.
Oh, great. That's great. I think that was the last question. Any more different question? Otherwise, I will just make the closing remark.
ते फक्त 2 नंबर 3 नंबर 14-15 स्लाइड पर एकदा दाखवा ना जरा प्लीज.
No, we don't have time. We have recorded this and we will circulate it. So you can watch it again. You can possess that presentation and see whenever you need it. Okay?
Okay.
Yeah, friends, thank you very much. I must compliment and thank Mr. Sarolkar for this wonderful presentation today. And really very good opportunities he has mentioned. One by one, probably this lecture, we allotted 40 minutes, which is not sufficient because each topic you need a separate presentation. Definitely, we will give an opportunity to Mr. Sarolkar to cover one by one and possible opportunities in Maharashtra. Friends, we have planned 2 lectures in July. The most important one lecture is by Mr. Prakash Raje. Prakash Raje is going to talk about selling value, not price. How to grow your business without discounting. Discounting is one of the negativity in any business, but still one can definitely, if he sells value and not price, he can definitely grow without discounting. So very important. Second lecture by Dr. Gangal, Shashikala Gangal, ex-Emirat, Pune University. And this is very important. Why education and industry research cannot be converted into a product. This is what we are listening for the so many years, industry, academia, relationship, so many things we are discussing. But till date, there is not a single research which is coming on the surface and improving the GDP of India. We need to focus on this because there is a lot of work going on in universities and research institutes. Need to be focused from the business angle. More and more patents should go on, and we should be able to convert those ideas into reality and useful for the mankind.